Hey, and welcome to NASA Launchpad. I'm your host, Alicia Sears. Think about how technology has changed your life over the past decade. In just 10 years, you have probably gone from this kind of computer to this. Our phones have gone from this to this. And when we want answers, the internet is just a click away with wireless connections available to us almost anywhere. NASA stays on the cutting edge of technology as well, and uses that technology to help us answer leading-edge scientific questions. But with all the questions we might want to answer, how do we prioritize the questions that are most important? NASA relies on the science community to help us. Once each decade, NASA and its partners ask the National Research Council to look out 10 or more years into the future and prioritize research areas, observations, and future missions. This special study is called the Decadal Survey, and the recommendations from this study will help drive not only space exploration, but space-based Earth science observations. One of the critical missions to come out of the latest Decadal Survey is SMAP.
SMAP is an exciting new NASA satellite mission. It's going to be an Earth orbiting mission, and we're scheduled to launch in October 2014.
SMAP will measure global soil moisture over the Earth every 2 or 3 days. It will also tell us whether that soil moisture is frozen or thawed.
We are all obviously aware that water is very necessary for life. You and I wouldn't be here if water didn't exist. But what people don't really stop to think about is that water is very important to the Earth as an integrated physical system.
Soil moisture works a lot like perspiration. When you exercise or you work up a sweat, the sweat evaporates and it serves to cool the body down. Soil moisture works very much the same way. As it evaporates, it cools the Earth's surface, it cools the lower atmosphere. It also provides water to the atmosphere, which then can grow clouds. It's also very important for plants, so some of the soil moisture will reach down into the root zone and feed trees and plants and crops.
Individuals can go out and stick their finger in the soil in their garden, and they know immediately whether they need to water their garden, and they know what will happen to their tomato plants if they don't water their garden. But if you multiply that by many, many times, you begin to get a feel for what the moisture conditions are across the state and the region. And the satellites allow us to measure very large areas in short periods of time, and then this information that they provide is very relevant to society in many different ways.
And in typical NASA fashion, the Soil Moisture Active Passive mission will be using brand new technologies to do something that has never been done before.
SMAP will be flying 2 microwave instruments that share a single antenna. The first instrument that they'll be flying is a microwave radiometer. The second instrument that we'll be flying is microwave radar.
One interesting features of the SMAP mission is the very large gold mesh antenna that the instrument uses. So as the antenna rotates, it produces a beam. Think of a flashlight beam. The flashlight beam, if you will, scans a large circular swath on the Earth's surface. That circular swath is 1,000 kilometers in diameter. So that allows us to measure a very wide swath of the Earth's surface as a satellite passes overhead. That's important because it allows us with a single satellite to measure the entire Earth's surface every 2 or 3 days.
Wow, a brand new map of global soil moisture every 3 days? That's a lot of data. But what sort of applications does all this data have?
What we want to do with SMAP is understand how water availability is changing around the globe. The total amount of water isn't changing on the Earth, but its availability in regions may change.
Certainly it improves our ability to predict floods and droughts.
It also has a more immediate effect and benefit for things like weather forecasting. The soil moisture data in weather models greatly improves the accuracy of our weather forecasts.
Having useful soil moisture information should be able to improve our ability to say something about agricultural productivity and food security.
It is very useful information that people are anxious to have.
So with more accurate soil moisture information, more accurate weather and climate forecasts could be made. But more importantly, data from SMAP will improve monitoring and forecasting events such as droughts, floods, and landslides. Whether it's farmers having more time to prepare for droughts or emergency workers having advance notice to plan for a natural disaster, SMAP will help us develop better forecast models for all sorts of situations. And with NASA's new technologies answering the questions of the decade, all of us will be able to make better, more informed decisions. That's it for this episode. Thanks for watching NASA Launchpad.